Alright, so a few notes on setting up the 5-axis in the Haas. When you put it in, there's a few different settings and a few different subroutines of probing that are a bit confusing. I don't fully comprehend. When the Haas guy came here, he didn't quite know the differences either. So, what I have found is, at least for this, putting a TRT trunnion system in a VF machine, not the UMC, there's a probing system in here. If you come to your edit VPS, where is that? Is that calibrations? Yeah, calibrations, Mrzp calibration. There's a bunch of different ones. Some of these are for the UMCs, more so I believe, which are a bit confusing because we can run them on this machine. But the Mrzp trunnion is the one we use, and it asks us a bunch of settings there. So that's the one we use. And what that does, when you put this guy in, we put this in, we make sure it's as flat as we can, make sure everything's clean. We rotate this guy 90, and we make sure with the A at 90, we take an indicator, make sure it's straight, we lock it down, we bring it back, we make sure it's flat. Once it's flat, you can set it in your rotary settings that it is flat. Then you'll come grab your Mrzp probe setting. It will tell you what to do, but you come over the bore of this thing, and it probes the bore, it comes up and it probes the face of this guy to make sure it's flat. If it is flat, it will tell you, okay, it will just keep going. If it's not flat, it will pause and tell you that it is now flat and to reset that setting. So it explains what to do. If you have to reset it, you just simply run it again once you reset that setting to tell it it's flat. Once it probes those sides, this is going to move 90. It's going to come probe the face. It's going to go -90. It's going to come probe the other face. And then that's it. And that's going to what I refer to as rough in, give you your rough Mrzp settings. Now, when you run that routine, it's going to give you your 300 to your 305 Mrzp settings. The 255 to the 257, I think, are mainly for the UMC machines. And now I comprehend a little bit better that those don't have some of the features. These 300 series ones are a little bit better. They allow you to fine-tune stuff a little bit more, and I'll explain that in a second. So those are the ones that inputs, those are the ones I like using now. So when you do that, it's pretty stinking close, but it is not perfect. So what we do is we run a test cut piece. Now Haas has a Mrzp calibration test cut thing that you run on the Haas. And I'd ran that before, and then I kind of came up with my own version, but that misses something critical, and it tells you something I think incorrect, which kind of threw me for a loop a little bit. Anyways, what we do is we put this piece in, you pick it up. Now this is all to set your dynamic work offsets and your tool center point control and all that. If you don't use that, well then you got to do all this manually anyway. So this is mainly for all of that stuff. If you're going to use that, which I suggest you do, it's way better. So what we do is we come in with the tool, with the machine at A90 with this block orientated like this, and we rough it. I'll show you guys the program maybe at the end of the video. We rough it, we finish the pass, we finish the side of the wall, sorry, with the profile pass of the tool. Yeah, and then I take it and I flip it, and I take that end mill and I run it half on and half off, and I face the edge of each one. Everything's at 0 to the CAD file of the block. I'm just machining the surfaces. So you rotate that, and then I take the same tool and I profile cut the face now. And I do that on all 4 sides. Then I come back up and I do kind of like a pocket that overlaps these faces. So the reason I'm doing all that, if all of your settings are correct, all of your tools in the different orientations with the same tool should blend perfectly. Haas says it should be less than 1 thou. For instance, when I threw this in and just ran the roughing pass, we were off by about 12 thou. Kinda. I'm usually off 6 or so thou. So, anyways, now you can take it and you can start tuning stuff. So, if this, you can kind of see you have these different witness lines, and I've got it pretty good so that you can barely see them. You have this surface, And then this other tool path up here you should be able to see it but not feel it. So that's perfect. Same thing up here. That's what you're going for. I can see where the tool cut here, and I can see where the tool cut a different orientation here, and they pretty much blend with the sub 1 thou thing. That's what we're going for. So different problems with this will tell us different things. If these cuts on these sidewalls are shifted, like if this wall has a big step and this wall has a big step, but these ones don't, what we will be adjusting is our X and Y slave coordinate systems. So the offset, X offset slave and Y offset slave, 303, 304. What that's going to do is adjust the center of that rotary independent of the A axis. It's going to adjust what is on this machine, the C axis. So in case that thing is not where it should be, we can adjust that and that'll get it off. Where it gets a little bit tricky is, so if you get those steps even, but now let's say you have like a 5 thou step all the way around, what the Mrzp test cut says is to adjust Z, and that's what I did this time, and I got that perfect. You adjust your Z master setting, because when you rotate, if the axis of our A, that has a Y coordinate and a Z coordinate. And if either of those aren't exactly where it is, when we rotate and this thing calculates it, we could be high, it could be low, or the part could be high. So what they're telling you when you adjust the Z difference is if that's not right, then your part could be higher than it thinks it should be, and that's why you get that even cut on these sides all the way around. Anyways, where it gets confusing is I adjusted my Z recently, and then when I wasn't doing this top cut, my part was off, but then when I switched to doing this top cut, now this top cut is way off and had a big step. So I just moved the step from this plane to this plane now, so I was a bit confused. Y also comes into that, the Y position of that A axis center line. I was moving Z and it was getting me something, but Y also comes into it. It's a bit tricky to explain, and after a lot of thought and stuff, I finally got it right. Just know that you might have to adjust your Y and your Z. I will tell you, in theory, Y should be more accurate. As long as you get that thing nice and square, your Y, once it's centered with the probe, should be pretty accurate. I put this thing in and out a lot, and I've never had to adjust Y. That's why it threw me for a loop last night. But just know that you might have to adjust your Y. So what I would do right now is adjust Z until it's good, and then hopefully this works out. If not, you move those. I was only out 2 thou on my, let's see, I was only out, I was out 3 or 4 thou on each of these numbers, Y offset master and Z offset master, and I was fighting like a 16 thou step all the way. It was either going here, and then I moved it over to here, and that's what threw me for a loop. So, and I had it comprehended that I had to move that master. Real quick too to explain, these are your master offsets for your A, because these offsets will control these offsets. These offsets are dependent on these ones. So these are your master offsets, and these are your slave offsets. Now your A is an axis that is going about, that is moving in X. Some of this stuff is anyways, it's moving in X. So it's not going to have an X position. It's going to have a Y position and a Z position. This guy right here is spinning about Z, so you're not going to have a Z position. You're going to have an X and a Y on those dependents. And that is why we use those 300 numbers, because we can move these independently and fine-tune it a lot better, to my comprehension anyways, than the 255 and 257 numbers. Those are only 3 settings. Over here, we have 6 or so settings to really dial stuff in. Anyways, that's my long explanation. I might do something later, but I'll also put a video of my test cut so you can see how I do the test cut. As long as the test cut comes out good, the machine is dialed and your parts will blend very nicely. A little thing too, you gotta run the test cut quite a few times. If you look at the Haas Mrzp one, which is a bit confusing but a good place to start, Mrzp test cut calibration procedure, they just say throw a new block in every time. All I do is I go change my CAD file and I move this wall in 10 thou every time I take a cut. So you do have to change the CAD file and repost it, that's a bummer. You cannot use the offsets. You actually have to be cutting to the geometry in your CAD. So that's why I got to move it 10 thou, and then I just move my G54 down 10 thou as well, and it leaves me some nice offsets. Or it allows me to do this a bunch of times. I've actually used this block so many times. I initially just was taking 20 thou off the edge, and I kept moving it in, and now every time I set up, I use this block and take my test cuts to down in. I hope that helps, because in my opinion, there's a great lack of information on the Mrzp settings in Haas, and some of them for the UMC. There's a bunch of different probe cycles that don't tell you why to use one, and they all do different stuff, and there's different numbers. But that's my thoughts on it. There you go.